backwards from the diagram, although it shouldn't be any more challenging. Let me go through this. The shaded area in this one above was what? It shaded all of R that wasn't Q. That was A for all R are Q. If it had been all Q or R, what would have been shaded? 2 and 3. If it had been no R or Q, what would have been shaded? 5 and 6. Excellent. And if it were all R or P, it would have been 7 and 6. So yeah, that was A. The X in the above represents the statement. If the X in P is in P, the first part of the sentence should be what? Yeah, it should be some P. Since the X is in P, it should be some P. So it can't be this. If it were some R, it would have to be somewhere in 5 or 6. If it were, and in this one, some RRP would have had to be where?
7.
Yeah, well, 7, but it's gone though. So given what we have there, it would have had to be in 5 if it were some RRP. Given what's left, I mean. So this one was some P, and you'll notice it's not in Q. So that's some P are not Q. Now finally it's asked, based upon the above diagram, which of the following statements can be validly deduced? Can we deduce some R are not Q? Nope. Where would the X be for some R are not Q? Oh wait, what am I talking about? Oh yeah, I am talking about that. Where would the X be for some R are not Q? It would have to be somewhere in the R circle. Why can't this one be some R not Q? Because an X would have to be 4 in 4 or 7, and guess what? Yeah, they're already shaded, so A is out of the question. B, some Q are not R. Where would an X have to be for some Q or not R? Thank you. 2 or 3, so it's not B. Can it be some P R Q? Where would an X be for some P or Q? 2. Yeah, 2 or 5 is some P or Q. So it would have to be in one of those, and it's not. By process of elimination, it is some P are not R. The X in one is a P, and it's not R. Now this is one of these working backwards kind of problems, which are fairly easy once you what?
Understand?
Yeah, once you get it and once you get the hang of it. It is admittedly working backwards. You will see one of these on the examination. That's not just a warning, it's a threat, whatever word you want to use for it. There will be a pre-done diagram, and I will ask you, what does the shaded area represent, and what does the X represent in the following statements? So you will see one of these again. Hint, hint. Now let's do this last one. Place the following argument into standard form and evaluate it for validity and explain. Let's do this. No good Christians covet their neighbor's house. Some evangelical Christians covet their neighbor's house. So, some evangelical Christians are not good Christians. Let's work this one. No good Christians, how about we use G for that? No good Christians, since Christian shows up another place, I'd rather not use C here, so we'll say no good Christians are persons who covet their neighbor's house. some evangelical Christians, some of you used E for that, understandably. I'm going to use V because I don't want to confuse it with an E statement. Some evangelical Christians are persons who covet their neighbor's house. Therefore, some evangelical Christians are not good Christians. All right, we've got 3 terms, each used twice but not in the same statement. Yeah, I wouldn't do it otherwise to you at this point. We've got the major term is in the first premise. We got the minor term, which is in the minor premise. So it's all right, it was already written in standard form. You didn't have to do anything to that one. Where did you see one where you had to flip them around? The second question on the homework that you had previously done for Monday. That was one where to put it into standard form you had to flip them around. I didn't force that on you here. The mood and figure are E, I, O, and the figure is 2. Have you seen one of these before? Yeah, I forget which one, but it was on a homework assignment. You've seen an EIO2 syllogism before. And if you remembered seeing it, you knew that it was what? Valid. Yeah, you knew that it was valid, but you still had what burden here? Because of what the question says. Yeah, to do some kind of substantial evaluation. Now at this point, you technically have 2 ways that you could have done this. Because on Monday we went over the rules method test. And I'm going to do both methods here, just to illustrate. We'll make this one G, this one H, this one V. Okay. I'm going to diagram no G or H by doing what? Shading 2 and 5. For some V or H, what am I going to do?
X.
Yeah, I'll be placing an X. There's only one place I can put it.
6.
6. That's some V that's H. 5 was also some V that is H, but it's shaded away, so that's out of play at this point. If you had made the mistake of attempting to diagram this premise first, you would have erroneously put it on the line and then had to go back and change it once you did this. That's why the rule is if you've got 2 premises, one is a universal, the other's a particular, always diagram which one first?
Universal.
Yeah, always diagram the universal one first, regardless of the order of them. Now, we can call the question, is some V or not G diagrammed here? Yeah, we already said it was valid, so yes. This one's valid. And all you had to say for this was, the X in 6 is a V that is not G. See, it's a V, it's in the V circle, and it's not G. So the conclusion has been demonstrated. Now, for those of you using the rules method, you could have just as easily shown that it was valid. However, what do you have to do in order to incorporate the rules method? You've got to show that what takes place. This on the board here. You got to show that it passes the negation rule And you have to show that proper distribution takes place. And what things have to be distributed? Remember, the rule is the middle term has to be distributed in one of the premises. The other rule is, if a term is distributed in the conclusion, it also has to be distributed in its corresponding premise. All right. Has the negation rule been passed? The negation rule says what? The same number of negations found in the conclusion will be found in the sum of the premises. Our conclusion is a what? Because it's an O statement, it's a negation. So we have one negation in the conclusion. How many negations do we have in the premises?
One.
Yeah, you better say one because you know that it's already what? You already know that it's valid. I'm just going through the process of using the rules method. The conclusion's a negation and only one of our premises is a negation. So it passes that rule. This is a negation, this is a negation, this one is not. Does the middle term distribute? If you got an E statement as one of the premises, you know that it won't break this rule. Why? For those of you who are here for the lecture, you remember that E statements distribute both the subject and the predicate. Now, because one of these is necessarily going to be the middle term, regardless of what comes next, you know that any syllogism that has an E statement as a premise will distribute the middle term. The middle term in this case is H, and it is distributed by the E statement. And it's because it's the predicate of an E statement, and E statements distribute both subject and predicates. You know that because that was where? The answer is it's in your notes. Now the other rule is if the conclusion, if there's any term that's distributed in the conclusion, it has to distribute in the corresponding premise. And for those of you who remember this from your notes, the conclusion is an O statement. O statements only distribute what?
Predicate.
Predicates. So what we have required here is G has got to be distributed, and it is. G is distributed as the predicate of an O, and it's also distributed in the premise as subject of an E. So it passes this test, it passes this test. Using the rules method is a little more cumbersome if your syllogism is what? If it's valid, because you have to go through a bunch of steps to demonstrate it. A little bit of writing, that's it. Take a guess when using the rules method will not be very cumbersome.
Invalid statement?
Yeah, if you see immediately which rule it breaks, all you have to do is explain which rule it breaks in order to show that it's invalid. The rules method is actually very easy to use if you immediately see which rule is broken. Because then all you have to do is explain which rule was broken to show that it's invalid. You may have the opportunity to do this where? Oh, that's on a quiz or an examination coming up. If you're given a question that asks you to demonstrate using either of the methods that we've learned, That means if you immediately see that it's invalid on that one via breaking one of the rules, you can use that. But do make sure you do what? You know the whole thing, show your work. In other words, verbalize it, explain it. That was the quiz, and some of you, I got those graded already and passed those back. Next thing's next. Did any of you folks want to see the rules method in action a little bit more?
Yes, please.
Good. I was expecting that and kind of hoping for that because some of our friends who may have missed part of class on Monday might need more than a refresher. Now, can somebody give me a mood and figure and we'll work through it? Any takers from the audience? Moods and figures are easy. I'll give you one. Suppose someone gave you an AAA2 syllogism. Now let's write it out. If my first premise is all P are Q, and I know my figure is figure 2, I know from memorizing my figure chart that Q will be my middle term, and because my second statement is also an A, it will look like this. What will my conclusion be?
All are RP?
Yes. You knew that it was all RP because it's an A statement, so you'll have all here. Because you know that this is the major term, it has to be the predicate of the conclusion. Minor term has to be the subject of the conclusion. Now, let's evaluate using the rules method. Okay. Now notice I'm writing this out longhand. If you were showing your work on a quiz or examination, and if you just wanted to use the letter N to represent negation instead of writing it all out, I will understand you. Does this pass the negation rule? Absolutely, because our conclusion is an affirmation, so there's 0 negations, and both of our premises are also affirmations. So we have the same number of negations in the conclusion as we do in the premise. It passes that rule. Now for distribution, remember the rule is that the middle term's got to be distributed in one of the premises, and the distribution rule pertaining to the conclusion is if the term is distributed in the conclusion, it has to be distributed in its corresponding premise. Is the middle term distributed? It's not distributed. Why isn't it distributed? Yes. The middle term is the predicate of 2 A statements. A statements distribute subjects only. So at this point, we can do what? We can stop and we can say invalid, and here's the technical term for it. The fallacy of an illicit middle term. Illicit is just a fancy Dan, for something that's that's not legal, something that doesn't follow the rules. Now, folks, if you decided to evaluate this before you did this, just for argument's sake, the rule is if there's a distributed term in the conclusion, it must be distributed in its corresponding premise. Is there a distributed term in the conclusion? There is, and based upon the fact that I was pointing at it, you probably could have inferred it anyway. A statements distribute subjects. So we have a distributed R in the conclusion, and we also have a distributed R in its corresponding premise. So it would have passed this rule if we had had to go that far. But it's invalid because it broke one of the rules. And all it has to do is what? Yeah, all it has to do is break one of the rules. How's that? Let's see two more, though. Let's take a look at two more. Suppose I have an I003 syllogism. Now, folks, do you suspect by just looking at it that it will be invalid or valid? You should suspect that it will be invalid because I had said that based upon those other two rules, we can also derive an additional rule that technically doesn't have to be stated. That if both of your premises are particulars, you're not going to be able to draw any conclusion. No categorical conclusion. Because one of the distribution rules or other will be broken. So let's write this one out. We've got some P or Q, and because it's third figure, we know that the P will be here. Sorry if I'm talking too quickly, because if you're still working these things through, I might be going too fast. If you've already worked these things out, you might think this joker's going too slowly. I do apologize on both counts. And because this is the major term, we drop this down. And because this is the minor, we drop this down. That's an I, that's an O, and we've got third figure. So we wrote that out longhand. Let's put our rules back up here. Now, one of the reasons why I picked this one is because we would have to go a little further. Why do we have to go a little bit further? Because it passes which rule? Yeah, this one passes the negation rule because our conclusion is a negation and only one of our premises is a negation, so it passes that test. Does the middle term distribute? I know at least a handful of you know the answer to this. Do we have a distributed middle term? Anybody?
Ready.
The middle term is P. It's the subject of an I statement. And what do you know about I statements? They don't distribute subject or predicate. P is in the second premise as the subject of an O statement. And O statements distribute what? Predicates but not subjects. So we've got an undistributed middle term. And if I were to give you a full account, it would be P neither distributes as subject of an I or an O statement. Now, I wrote the whole thing out to show you what a full-blown explanation would have to look like. It's invalid due to an illicit middle. And by the way, we are not doing geometry here. But why might this, what we're doing right here, give you a bad geometry flashback if you happen to have had a bad experience? What's that? Yeah, it's a proof. We're doing a rigorous method of proof by which you have to demonstrate how you can draw the conclusion that it's valid. And we're also appealing to these, we're also appealing to rules that need to be followed. It's way easier than a 10-step geometry proof that I remember from 9th grade or whatever it was. But anyway, let's look at one more. Does anyone want to give me a mood and figure? Any takers? Yes, sir, Mr. Smith. AEO4. I can tell you right off the bat that this one will be invalid. Does anyone know? We're going to go through it though. Does anyone know why I can tell you right off the bat that it will be invalid? The short answer is my premises will force me to do what to the diagram if I were doing a diagram? Will have me shading the diagram. What does the conclusion require I have in the diagram?
X.
An X. There will be no X's in that diagram. The conclusion will require an X. There will be no X. Therefore, there must be something wrong with this particular syllogism. And to put it away, Mr. Hunter, I think, would appreciate because of his question last time. You can't derive a particular if both of your premises are universals. That is a rule that's actually derivable from our other rules. If both of your premises are universals, you can't derive a particular. Because that would make the bad presupposition that the universals are talking about things that what? That actually exist. And it's quite possible that a universal statement might be true, even if there's actually no real members that exist. There may just be conceptual members. All unicorns are is a true statement. But if I said some unicorns are, that would be false. Because unicorns what? As far as I know, outside of My Little Pony land, they don't exist, or whatever fantasy world you may have had cooked up for you. But anyway, I'll shut up about this.